To convert binary number to decimal, we are going to use multiplication. I'm going to multiply each bit by 8n. So now I have octal value 16 to the power 0 means 1. So 12 into 1, I'm going to get 12. Convert each octal digit to a 3-bit equivalent binary representation. Hello to all, a warm welcome to my new session. I am Revati, faculty, Department of Computer Science, Vidhyaashram, 1st grade college, MYSURU. We are on the second session of Introduction to Number System. Moving further, we are in the agendas of today's session. In today's session, I'll be dealing with conversion from one number system to another number system. Before going to start today's session, I want to recall the things what I discussed in my last session. In my last session, I discussed what is number system. Under number system, we discussed the two different types of number system, that is positional number system and non-positional number system. So the non-positional number system, the example is Roman numbers, whereas for the positional number system, we are going to get 4 different types of positional number system. That is binary number system, then decimal number system, octal number system and hexadecimal number system. But in today's class, we are going to study the conversion from one number system to another number system. Moving further, we are going to get binary to decimal conversion. So what is binary number? We know the numbers are represented in the form of zeros and ones. Then what about decimal number? So in decimal number, the numbers are represented in the form of 0 to 9. Total it is 10. So then how to convert the binary number into decimal? So here to convert, we are going to use multiplication. That means to convert binary number to decimal, we are going to use multiplication. So multiply each bit by the value 2. So that is 2n. Then what is weight here? Here weight is nothing but the position of each bit. I repeat, here weight is nothing but the position of each bit. So for example, consider this one. What is the position here? So I'll start from 0. Then what is the next position? It is 1. Then it is 2. Then it is 3. Then it is 4. And then it is 5. So I repeat, in binary to decimal conversion, multiply each bit by 2, where n is the weight of the bit and weight is nothing but the position of the bit. And at the end, you want to add all the result together. So this is the example. What is the example? Here I have 1 0 1 0 1 and 1. Now I want to convert this binary number to decimal. So what I will do? First I'll write the position. It is 0th position, it is 1, it is 2, it is 3, it is 4 and it is 5. Now I will write 1 into 2 plus 0 into 2 plus here 1 into 2 plus 0 into 2 plus 1 into 2 plus 1 into 2. Now here I am going to write the power of this number. So initially it is 0th power, it is 1, it is 2, it is 3, it is 4 and it is 5. So now I am going to multiply. So what is the value? That is 2 to the power 1. It is 1. 1 into 1, it is 1. Then I'll write plus Then I'm going to consider this one. What is the value of 2 to the power 1? It is 2. 2 into 1, it is 2. Then I'm going to consider third bit. What is the power? That is 2 to the power 2. Here it is 4. 4 into 0, I'm going to get 0. Then plus. So 2 to the power 3. 2 to the power 3 means how much? It is 8. Then 2 to the power 4 means how much? It is 16. 16 into 0, it is 0. Plus 2 to the power 5. Here it is 32. Now I'm going to add these all the values together. Then I'm going to get 43. Now it is the binary conversion. That means the binary conversion of 101011 is 43. So moving further, we are going to get octal to decimal. I repeat, we are going to get octal to decimal. So what is octal? In octal, we are going to get 0 to 7. So total it is 8 numbers. 8 is nothing but your octal number. So decimal, once again it is 0 to 9. Total it is 10. Now I want to convert my octal number to decimal. So how to convert? To convert, what I am going to do here, I am going to multiply each bit by 8n. So now I have octal value. So I am going to multiply these by 8n in order to convert into decimal. So where weight is nothing but your position. That means where n is weight, your weight is nothing but the position of each bit. So consider the example. What is the value? We have 7 to 4. Now I'm going to write the weight. So this is the position. What is the position of 4? It is 0. Then what is the position of 2? It is 1. Then what is the position of 7? It is 2. So now I'll write 4 into 8 to the power 0 plus then 2 into 8 to the power 1 plus 7 into 8 to the power 2. So 8 to the power 0 means how much? It is 1. So 4 into 1, I'm getting 4. Then 8 to the power 1 means what? It is 8. 8 into 2, I'm getting 16 plus 8 to the power 2. That is 64 into 7. I'm going to get 448. Now I'm going to add all these values together. So I'm going to get 468. Now this is the octal. Now I have octal number. What's the octal number here? 724, and that is represented in the form of decimal. So what is the conversion value here? It is 468 of 10. That is base 10. That is the conversion of octal to decimal. Moving further, we are going to get hexadecimal to decimal. So what is hexadecimal value? What is the range? Here it starts from 0 to 15. Total it is 16. What is decimal then? Once again, it is 0 to 9. Total 10 number. So 10 is nothing but your decimal number. So here I'm going to multiply each bit by 16n, where n is the weight of the bit. I repeat, where n is the weight of the bit. Here weight is nothing but the position of the bit starting from 0 on the right. So you're going to start from 0 to the right. So Then I'm going to add all the result. So the procedure is same. Here we are going to get hexadecimal number. What number we are going to get? We are going to get hexadecimal number, that is ABC. So what is A stands for? Here A stands for 10, B stands for 11 and C stands for 12. Now I'm going to multiply these values with 16, that is 16 power. So what's the position of C here? It is 0. Then what's the position of B? It is 1. Then what's the position of A? It is 2. So I'm going to multiply C with 16 to the power 0, that is 1. 16 to the power 0 means 1. So 12 into 1, I'm going to get 12. Then 16 to the power 1, it is 16. 16 into 11, I'm going to get 176. 16 to the power 2, it is 256. I'm going to multiply 256 with 10. So I'm going to get 2560. Now I'm going to add all these values together. So I'm going to get 2748. Now I want to write the base. So it is decimal conversion. So I'm going to write 10. So the actual value, what it is, hexadecimal value ABC. After converting ABC, I'm going to get 2748 decimal value. Moving further, I'm going to get decimal to binary. I repeat, here it is decimal to binary. So here we are going to get decimal number and the range starts from 0 to 9 and it is how many numbers? It is 10 numbers. So what is binary? It is 0 and 1s. So 0 and 1, it is only 2-bit representation. So here I want to divide each number by 2 and I am going to keep track of the remainder. So here I am going to consider the remainder and the first remainder is the LSB, that means least significant bit, and the second remainder is the bit 1. That means, so the first remainder, whatever the remainder you're going to get, that is your LSB. Then the second remainder is bit 1. Now consider the example. What is the example we have? It is 125. That is 125. This is my decimal number. Now I want to convert this decimal number to binary. For that's why I'll start dividing from 2. 2 6 are, it is 12. So I'll write 6. Okay. Then I have 5. 2 2s are, I'm going to get 4. That is 5 minus 4. How much? 1 is remainder. Now, once again, I'm going to divide by 2. 2 3s are, it is 6. 2 1s are 1. So, what about remainder? It is 0. Once again, I'm going to divide this number by 2. 2 1s are 2. What is remainder? It is 1. That is 3 minus 2. It is 1. So, it is 11. I have 2 5s are, it is 10. 1 is remainder. Once again, divide 15 by 2. 2 7s are, it is 14. 1 is remainder. Then 2 3s are, it is 6. 1 is remainder. Then 2 1s are 2. 1 is remainder. Now I am going to write all this remainder value together. So how can I write? So here I'll start from here. 1, 1, 1, 1, 1, 0, 1. This is the binary representation of decimal number 125. So here this is the binary representation of 125. Moving further, we are going to get octal to binary. That means we have octal value. Now I want to convert this octal value to binary. So the octal value ranges from 0 to 7. Total it is 8. Once again, binary is ranges from 1 and 0. Total it is 2. How to convert then octal to binary? So to represent 0 to 7, we required 3 bits. So here convert each octal digit to a 3-bit equivalent binary representation. That means convert each octal digit to 3-bit equivalent binary representation. So here I'll write 5. What is the value of 5? What is the binary value? It is 1, 0, 1. Then what about 0? Once again it is 0, 0, 0. And what about 7? It is 1, 1, 1. At the end, I'm going to write all 3 values together. So this is the binary representation of octal number. What's the octal number here? It is 705. And what's the binary equivalent? It is 111. That is 3 times 1, then 3 times 0, then 101. Moving further, we are going to get hexadecimal to binary. That means I have hexadecimal value. Now I want to convert this hexadecimal value to binary. So what is the range of hexadecimal value? Once again it is 0 to 15 and the range is 16. That means total you're going to get 16 number and range starts from 0 to 15. Whereas in binary it is 0 and 1. So it is only 2 bits. So then how to convert decimal to binary? So here to convert hexadecimal to binary, I'm going to convert each hexadecimal to a 4-bit equivalent binary. I repeat, I'm going to convert each hexadecimal to binary. How? I'm going to consider 4-bit equivalent. So this is the actual hexadecimal value. So what I will do? I'm going to consider each bit separately. So what I will do? I'll write 10AF. That means I'm going to consider each bit separately. So this is 1, this is 0, this is A and F. Now I'm going to write binary equivalent for the particular bit. So F, what is the binary value for F? It is 41. Then what is the binary representation of A? That means A means how much? 10. So the A's binary representation here is 1010. Then 0, the binary representation as it is for 1, the binary representation is 1. So in hexadecimal to binary, we are going to convert each hexadecimal to a 4-bit. I repeat, a 4-bit equivalent binary representation. So what I will do, I'm going to consider individual bits separately and I'm going to write the binary equivalent for that bit with 4-bit representation. So this is the actual representation. Now I'm going to club all these bits together. That is the binary representation of hexadecimal value 10AF. Moving further, we are going to get decimal to octal. So here decimal number means how much? Once again it is 0 to 9, total 10 numbers. Then octal 0 to 7, total it is 8. That means the range starts from 0 to 7, total 8 numbers. So here to convert decimal to octal, we are going to get decimal number. I want to convert that decimal to octal by dividing by 8. So this is the actual representation. So I'm going to divide by 8 and I'm going to keep the remainder. Here now I have hexadecimal value 1234. Now I am going to convert this 1234 to octal number. So I'm going to divide this value by 8. So here 8 ones are 8. 12 minus 8, it is 4. So I'm going to write 3, it is 43. 8 5s are 40. What is remainder? 3, remaining 3. So I'll write 4 once again. 8 4s are, it is 32. Then how much it is remaining? 2. So here I'll write quotient, remainder 2. So I'll write remainder 2. Once again, I'm going to divide 154 by 8. That is 8 ones are, it is 8. 15 minus 8, how much? 7. So 8 9s are 72. 4 minus 2, it is 2. What is my remainder? Here it is 2. 8, now I have 19. I'm going to divide 19 by 8. So 8 2s are 16. What's the value remaining? It is 19. I'm going to divide 19 by 8. 8 2s are, it is 16. So what is the remainder? 3. So this is the actual value. So I'll start writing from 2, then 3, then 2 and 2. This is the octal representation of the value 1, 2, 3, 4. Moving further, we are going to get decimal to hexadecimal. So what is the range? Once again, it is 0 to 9, total 10 numbers. Then what about hexadecimal? 0 to 15, total it is 16 number. So to convert decimal to hexadecimal, I am going to divide the given number by 16 and I am going to keep track of the remainder. So what is the value here? I have once again the same number. It is 1, 2, 3, 4. This is the decimal representation. Now I want to convert this decimal number to hexadecimal. So what I will do? I'm going to start dividing from 16. So 16, this is the value. So 16 sevens are, that means 1677. I'm going to get 12, 3, 2. So actually I have 12, 3, 4 value. So if I subtract, what is the remaining value? 2. So this is my remainder. So I am having 77 and 16. I want to divide 77 by 16. 16 4s are, it is 64. That is 77 minus 64. It is 3, then 1. What is the remainder? It is 13. So 13. So here it is a hexadecimal number. Now I want to write it in the form of hexadecimal number. So 13 means it is D. I repeat, 13 means it is D. Then what about this one? This is the quotient. That means 16 fours are 64. The 13 is remainder and 4 is your quotient. But while writing the result from this, you are going to write 4. It is D and 2 of 16. Here base 16 means this is the hexadecimal representation of the number 1, 2, 3, 4. Moving further, we are going to get binary to octal. Think that we have binary numbers. Now I want to convert this binary number to octal. So what I will do? I'm going to represent 3 bits together. Why it is 3 bits? Because it is octal number. So I'm going to represent 3 bits together starting on right, and I'm going to convert those bits into octal digits. So what is the value I have? I'm going to convert 3 bits together. Then I'm going to write the binary values as it is. That means I'm going to group 3 bits together. Then I'm going to write the equivalent octal number. So if I get 3 ones, then it is the octal representation of 7. Here 0, 1, 0. This is the octal representation of 2. 0, 1, 1, it is 3, and 1, it is 1 as it is. Now I'm going to write all these values together. So this is the octal representation of this binary number. Moving further, we are going to get binary to hexadecimal. So here we are going to group 4 bits. Dear students, just remember that in octal we are going to combine, or we are going to club 3 bits. Whereas in hexadecimal we are going to group 4 bits together starting on right to convert hexadecimal digit. To convert hexadecimal digit. That means we are going to group 4 bits together. So this is the actual binary representation. Now I want to convert this binary number to hexadecimal. So what I want to do? I want to group 4 bits together. So this is the way to group 4 bits together. Now I'm going to write the hexadecimal values for those bits. That means hexadecimal equivalent to binary value. So here I have binary. Now I want to write hexadecimal equivalent to this binary value. So here 1011 means it is B. B means how much? It is 11. I repeat, it is decimal number 11. So cross verify. I'm going to divide 11 by 2. 11. That is 2 5s are, it is 10. Then what is the remainder? 1. Then 2 2s are, it is 4. 1 is remainder. Then 2 1s are 2 and 0 is remainder. So this is the actual number, that is 1011. So in hexadecimal it is B. Once again we have 1011, it is B, and we have 10, it is 2. Now I am going to combine all these values together, that is 2BB of 16. So this is that is 2BB of 16. This is the hexadecimal value. This is the hexadecimal equivalent to binary value 10103111. Moving further, we are going to have octal to hexadecimal. So, to convert octal to hexadecimal, once again, I am going to use binary is as my intermediator, because I cannot convert octal to hexadecimal directly. So what I will do, I am going to take the help of binary. So what I will do, this is my octal number. I am going to write the binary representation for octal number. So what I will do, I am going to split this number separately. So first I'll write 1, then I'll write 0, then I'll write 7 and I'll write 6. Now I'm going to write the binary equivalent of that particular octal number. So 6 means it is 110. 7 means it is 110. What is the binary equivalent for 0? It is 00. What is the binary equivalent for 1? It is 001. Now, what I will do, in hexadecimal, I am going to group 4 bits together. I repeat, in hexadecimal, I am going to group 4 bits together. So, what I will do, I am going to group 4 bits together. So, here it is 1110. That means it is E. E is nothing but it is 14. So here I am going to get 0011. So it is the decimal representation 3. Then here I am going to get 0010. So it is the decimal representation or hexadecimal representation 2. So the hexadecimal value we have 23E. So in hexadecimal we are going to group 4 bits together. So I'm going to group 4 bits together. Now I'm going to write the hexadecimal equivalent to binary. So if I consider 1110, what is the hexadecimal value for this binary equivalent? That is E. E means how much? It is 14. If I get 0011, then what is the hexadecimal value? It is 3. If I get 0010, then what's the hexadecimal value? I'm going to get, it is 2. Now I'm going to combine all these 3 values together. That is 23E of 16 means this is the hexadecimal representation of the given octal number 1076. Moving further, we are going to get hexadecimal to octal. I repeat, here we are going to get hexadecimal to octal. So here we are going to use binary as an intermediator because it's not possible to convert hexadecimal to octal directly. So what I will do? I'm going to take the help of binary conversion. So what I will do? Initially, I'm going to split the given hexadecimal number. Then I'm going to write the binary equivalent for that hexadecimal number, and at the end I'm going to group 3 bits together because in octal we are going to group 3 bits together. So initially what I will do, I'm going to split this hexadecimal number. Now I'm going to write the binary representation of this hexadecimal number. So here C means how much? It is 12. So what is the binary representation of 12? It is 1100. Then here 0, what is the binary representation of 0? It is 4 zeros. then F means 15. Then what is the binary representation of 15? It is 4, 1. I repeat, the binary representation of F is 4, 1. Then what is the binary representation of 1? It is 1 once again. Now I have my bits. Now I am going to group all these bits in 3-bit differently. So what I will do, I am going to consider 3 bits. I am going to divide 3 bits. Then I will write the values. So here I have 100, that is the binary number, and what is the octal value for that binary number? It is 4. So if I have 001, then what's the octal value I have? 1. If I have 100, what's the octal value? It is 4. Then if I have 3 ones, then I have octal number 7. If I have 1, then I'm going to have octal value 1. At the end, I'm going to combine all these values together. So 17414 of 8. That means this is the octal representation of the given hexadecimal number 1F0C. Hexadecimal value and the equivalent octal value is 17414. So dear students, in today's class, we studied different types of conversion. That means from one number system to another number system. That means it is possible to convert binary number to octal, decimal and hexadecimal. At the same time, it is possible to convert octal to decimal or octal to hexadecimal and octal to binary, so and so. Dear students, in my last session we studied number system. Under number system we studied positional number system. There we studied binary number system, octal number system, decimal number system and hexadecimal number system. But in today's class, we studied the conversion from one number system to another. Dear students, just remember that the computer, that means electronic machine, can able to understand only binary numbers. So it is very important to convert one number to another. So in the next class, I'm going to deal with multiplying powers. Then I'm going to discuss binary addition, binary multiplication, binary subtraction and binary division. And at the same time, I'm going to discuss ones complement and twos complement method. So in today's session, we studied the different types of conversion from one system to another. So it is possible to convert all the number systems of positional number system. It is possible to convert all the types of positional number system. So I hope in my today's class you got more information about number system and the conversion from one number system to another number system. Thank you for watching my session. Let's meet in the next session. Until then, take care. Thank you.